Hey there, physical science students. This is Ms. Ruark. This is Vodcast 4.1, where we're going to talk about electric charge and force. We're going to be dealing with electricity now. All right, so electrical charge and force. You see the picture on the right. There's a guy who's walked across a carpet, and he goes to grab the doorknob, and it zaps him, right? Or it shocks him. You're like, ow, it hurts. Well, why does that happen? Well, your body's going to pick up an electric charge as your shoes are shuffling across the carpet. And what's happening is, excuse me, as your shoes shuffle across the carpet, there's a transfer of electrons. So the electrons from the carpet, which is neutral in charge, are now being pulled into your shoes. Your shoes are going to pick up that negative charge. When you're walking, you don't feel it because it's spread across your entire body. But once you go to touch something else that is a conductor, such as a metal doorknob or another person, it all gets concentrated and sent through your finger. And there you'll feel it because it's all in one spot instead of being distributed across your body. All right, so what is an electric charge? Well, an electrical charge, it's a property, an electrical property of matter. It can be positive, can be negative, or it can have no charge at all. Positive and negative charges are said to be opposite. And if you have equal positive and negative charges, there will result in no charge because they will cancel each other out. Okay, so like charges will repel each other. Opposite charges will attract. And electrons are going to be transferred from one object to another when they are rubbed next to each other. So this picture here, you guys have all had, well, maybe not all of you. If you have longer hair or hair that does kind of what it wants to do, when you go to put your sweater on or when you go to put your hoodie on and it's dry out, especially now during the colder months, your hair experiences this static electricity. So what's happening is that your hair, as it's being rubbed against the sweater or the sweatshirt material, it's actually picking up those electrons. And those electrons don't want to be close to each other. They want to repel from each other. And that's what makes your hair stand up on end like this, because they don't want to be near each other. Right? They repel each other because of the same charge. Well, why does your hair then stick to your clothes and your skin and everything? Because your skin and your clothes now have that positive charge, and since there's opposite charges there, positive and negative, they want to come together. All right, so what is the direction in which these electrons are going to be transferred? Well, it depends on the materials involved. Okay, so what kind of materials can you have? Well, you can have conductors and you can have insulators. Conductors will allow those electric charges to move, and they're going to be able to move freely, okay? Freely or easily. And examples of conductors would be metal. Not sure what that is right there, but most metals, silicon, and then your insulators are things that do not transfer charges easily. They do actually allow some charges to go through, but they don't allow it to happen easily. So they try to prevent, but don't completely prevent. And examples of those would be plastics and rubbers. And right here is a wire, a copper wire that has been coated in a rubber casing, right? The metal here would be the conductor, and then the rubber casing would be the insulator, and the insulator is put there to direct the flow, because we don't want those electrons, we don't want that electricity or that electric charge to be flowing out. We want it to go from whatever it's plugged into to whatever it's plugged into on the other side. All right, so how can we charge an object? Well, you can move charges within an uncharged object, and you can do that by placing a charged object next to it. Okay, so if we were to take, and there's not really a good picture of it here, but I guess this will work. Okay, so here, well, let's finish this up. Objects can be charged by contact, and then they can also be charged by friction. All right, so let's explain these three, because these can all be explained with these two pictures here. So, An object can be charged by contact. That would be the picture down here. You take something that has a negative charge and you put it next to something that has a neutral charge. And the electrons can flow from the charged substance into the uncharged. And here you have it's now has a negative charge to it. Okay, so that's by contact, where there's an actual transfer, kind of like conduction, a transfer of the electrons. All right, by friction would be numbers 1 and 2 up here, where you have this balloon and you put it next to a piece of wool and you rub it up and down, kind of like taking a balloon and rubbing it on your sweater, and then the balloon will stick to things, right? Well, the reason for that is because as you take this balloon and you rub it up and down, you notice how this has these negative charges in it. Well, guess what happens? Those negative charges have now added themselves onto the balloon. That would be by friction, okay? They've now added themselves to the balloon, and that's why it would stick to the wool, because the wool now has a more positive charge and the balloon has a more negative charge. Well, if we take that same balloon that we've rubbed up and down on that piece of wool that now has more electrons on it, and we stick it next to a wall. The wall is an uncharged object. It does not have a positive charge to it. But what it does is it makes those negative charges that would normally be here, they move them. And those charges have moved away. Okay, so what you have now here is more positive charges. Okay, it's not that the wall has a charge to it, it's just that it has moved or pushed those negative charges away because they're repelling each other. And so those positive charges are hanging on the wall, and they are what attract the balloon to it, and that's how the balloon will stick to the wall. All right, so what if I was to take 2 balloons and rub them on a piece of wool? Well, both balloons will end up with a negative charge, and those will repel each other because they have the same charge, and they have this thing called an electric force around them. Okay, so I know you've probably felt it when you take magnets and you try to stick them next to each other and they're kind of pushing away from each other, but they're not touching it. That's because their electric force is repelling. Okay, so what is an electric force? An electric force is a push or pull on nearby objects. It pushes if they are the same charge, and it pulls if they are opposite charges. All right, well, how can we get that electric force to get smaller? How can we get that electric force to decrease? Well, if we take those 2 objects, those 2 balloons, and we put them next to each other, they're going to repel. If we take them and put them far away from each other, it's not going to matter. So distance is going to decrease the effect of that force. And the force acts through this thing called an electric field. Now, each charged particle has an electric field around it. Positively charged particles, the electric field is pushing out. Okay, positively charged pushing out, you might want to write that down. Negatively charged particles, the force is pulling in. So when we take, this is if these 2 particles were just standing by themselves. Now if we take these 2 particles and we put them close enough to each other, the positives are going to push into the negative, and it creates this field, this force field. I like that. All right, that goes around the charged particles, and that's how you get that push and that pull here. Okay, so think if we took 2 positives and put them next to each other, they would have pushing and pushing, pushing and pushing, and they would not be able to get near each other. Okay, same thing with the negatives. So you've got this push and this pull. Remember, the field always goes from positive to negative. Always goes from positive to negative. Might be important. You might want to write that down. Always. Always. Okay, and I thought that was kind of funny. That would be an electric fence. Okay, that's it. So I guess I'll see you in class.